stream. Right. Let me double check it. Okay, audio is working correctly. Cool. Let me check the stream as well, just to make sure that it's all working correctly. Channel, right. And then videos. Wait, can I go to my channel, please? Thank you. Okay, there we go. Okay, that seems to work good. Okay. Right. Welcome everybody to the stream. So yeah. So today I wanted to continue working a little bit on the Raytracer. So to show you what I have been doing, I will put it up real quick and I will show you. Right. So what we can see, we worked on shading last time. Or sorry, not shading, what am I saying? Reflections, right? However, I have been talking to some people, doing some research about this, and I found out that the way I'm doing reflections is wrong. So I plan on fixing that today. Right, so for the I think the fix should be relatively simple. So with this, right, it's this is a bit more nuanced, this part. So first of all, we have the reflection. That's fine. Then we have the texture color here, what is from the texture of the material, and then we apply shading. Okay. However, this is all a bit more nuanced, right? So how we change this is the reflect already takes into account the reflective index, right? So we say, oh, it reflects 20%. However, what it happens if where is it? In here, apply shading. This is a bit more nuanced, right? So this is times 1.f minus hit info.material.reflective index, right? Because everything that gets reflected doesn't get shaded, right? Because it's getting light from somewhere. So then we say, well, return shading results plus reflection results. So now this should give us actually the correct result. Hopefully. Okay. That is very bright, I'm got to admit. Interesting. So let me go to the material file. R2 material. No. Material.h. Okay. Oh. Wait. Oh, we're already in there? Huh? Oh. Huh? Oh, yeah, of course I put the get texture in there. My bad. So this is by default equal to 0, and the same for this. So by default there's no reflection and no refraction. Okay. Right, just to make sure that's white. Okay, interesting. So why is this left one completely white? This might be the way I've set it up in here. Right, so model 2, it's loaded material base color is this. Okay, sure. Raytracer. So why is this completely white? Because it should have the They should have the potato texture as well. But we can see the potato texture here, and this is the reflection, right? So I am kind of curious about this. Why this is, or doesn't have the material at all. Okay. So let's go to application again. Put a breakpoint here and then run in debug. Right. So the loaded in material, does this throw anything in the console? No, it doesn't. Okay. Right, model 2. Oh, wait a second, this is interesting. So it isn't showing my debug hovering. Okay, that's interesting. Right, okay. But we can still check this, right? So the texture is valid. So this is 0, this is 0 as well. Okay. Sure. Good evening, Beryl. How you doing, man? Right. Okay. Apply shading. Yeah. So if I make this non-reflective as well, okay, what happens? Oh, I can't handle that music. Okay. Okay, interesting. So apparently when I turn off the reflectiveness, it becomes completely white now. Sure. That's interesting. Okay. So let's go back to the Raytracer. Yeah, Beryl, thank you for joining the stream again. It's good having you around. Yeah, no, I don't plan on streaming it for too long either. So I just want to do like an hour or something, hour and a half. But yeah, I'm doing good. The cable arrived for my camera, so now my camera won't run out of power midstream. So I got like a fancy camera like for streaming, and I forgot the dummy battery, so I just had like the actual battery, right? So this would, I thought it would only last like 20-30 minutes. However, it seemed it last time like around the 2-hour mark, what is actually much better than I expected. But now it has like a dummy battery, what is actually connected to the power, right? So the camera thinks it has a battery inside of it. However, in reality, it's just like constantly being fed power. Was pretty cool. But luckily, I ordered it yesterday, and I thought it would come in tomorrow, but it came in today. So I'm testing it now. Oh, okay. I see what's wrong. So this shouldn't return, this should return 0. Okay. Okay, this should fix it. There we go. So now the potatoes are correctly shaded. Then if you go back to the application and turn this to 0.6, we should see that the shading is now done correctly. Yeah. Okay. I think this is fine. I've always opted to wired when offered Bluetooth alternatives. Oh yeah, definitely. So yeah, I really hate Bluetooth. The only thing though, so I got this headset and this cable always gets tangled up, right? That's the only thing why I would consider a Bluetooth headset. But then the DD770s and the DD90, so the Biodynamics DT77 and the DT9090 Pros are so awesome I wouldn't switch them out. Right. So what I want to say, this is actually correct, what I have been doing here, right? So what I changed was in here, right, so this is now changed, that it adds the results. However, you do shading and reflection. So if you reflect, that means you get light, right? Because let me open Paint to explain this. Paint. No. Okay, there we go. Okay. Oh, it's capturing the wrong display. Oops. There we go. Okay. So we have our beautiful scene again. Scene. So this is potato. Okay. So when we reflected before, we would say, oh yeah, but this doesn't hit right, so it should be black. Oh, sorry, so this should be this pixel color. However, what I failed to realize is when we hit here, for example, and bounce off, we said before, oh no, but it doesn't hit anything, it should only do shading. However, we get the background color here, right? And because the black background color isn't lit, the background color is lit because it's a color, right? If there is no lights, it would be black, but there is lights, so it gets the background color. So it's a mix. So if the surface is 50% reflective, that means that we would still apply shading here, but only 50%, because the other 50%, it gets the background color. Right, if that makes sense. So I wasn't doing that properly. So now I changed that to do take it into account. So this, the reflect here, the color, gets multiplied here by the reflective index. And the same for the shading, but then it's 1 minus, right? So if it's, say, 30% reflective, this would be 70%. So it would apply 70% shading. So if we were to make the background, say, black, right, we should see the actual shading. Right, so we can see now that it's actually lit correctly. And we can see a bit of reflection here of the correct surface. So let's change this by making the potato green. So application, show the top potato. That will give us a bit starker contrast on the reflection. No, okay, that was clearly wrong. What did I comment out that I shouldn't be commenting out? Oh yeah, that's bad. This line, sorry, oops. So now the top potato should be white, so we should be getting a bit different, yeah. So we can see a whitest, we can see some reflections here of the white potato. I think this is correct. So if we make this a perfect mirror, so if say 0, 0.1, what happens then? Right. So we can see only a tiny sliver is hitting this. What could make sense. So what I want to try is put this back, and I want to get a cube model. Wait, really? Is there not brown? Right, I got a cube. Okay. So why does brown not exist then? Right, so I got a cube model now, and we can replace this by loading, instead of assets, we load cube.obj. Right. I mean, in the Raytracer I can, Um, this is interesting. Wait, let me change the Raytracer back to have a background color. Because this is kind of hard to see. Okay, so we do have the cube, however we could only see one face, right? Because the lighting. And we can only see a tiny sliver here. Right, so I just realized I did this wrong. Okay, so this should be potato and this should be cube. I think I could generate brown light if I had the RGB color combination. However, I suppose it might be dark orange. Huh. So instead this should be positioned at 0, 7. Yeah, sure. So this is a perfect mirror, but it should be less than a perfect mirror. Right. So why is this not generating anything? Huh, interesting. That's actually really, really interesting. I really didn't know that actually. But that's yeah, thank you for the explanation. Right, so set position. So I'm just kind of curious why the cube isn't being generating. Oh, okay. Why the cube is being annoying. Because we should be able to see the potato being reflected in it. Because the potato is right above it. However, we're not seeing anything. Although, the normal view might help a bit. Yeah, no, I think that's okay. I think our camera might simply not be able to see it. Yeah, I think that could be happening. Camera. So let's put this up a little bit to like 7. Oh yeah, no, of course it doesn't reflect because it doesn't reflect straight up. Right. So this would we would actually put the potato somewhere like here. So we would put this on like position 10 and this on 0 as well. And then put the camera back to like 3. I hope with this that we can see the oh, that looks good. However, it's inside of the. You're telling me that pink is now also not a real color? I think my life has been a lie. I've been told all these colors exist, right? But apparently none of them do, and I think my life is honestly ruined now. I thought colors existed, but like, what colors do we have then? Oh, there we go. I think this works, right? I think, yeah, this looks correct. Because it's, yeah, in here it's reflecting. Okay, that's awesome. No, I think that's definitely correct. Yeah, because we can see the potato zooming along. Okay, that's awesome. That looks weird though. But it makes sense though, because the angles keeps changing. Okay. Something else I've added, right, is a depth view. So it kinda changes the depth based on so you can kind of see how deep the how deep it's going. So something I have been wanting to do as well is potentially see how expensive a pixel is to calculate. What I'm wondering how to do, because you could go with recursion, but that might be kind of hard. I could see with BVH intersections. But holy, the FPS is dropping massively actually. Yeah, my CPU is completely busy. Okay. So it seems since we added reflections, the performance has been down massively. So if we turn off this light, does my performance become much better? I'm just curious. Not really. Okay. Okay. Interesting. So at least I think this is looking much better. Yeah, this is definitely looking much better. Right. So next up, I guess we can do refraction. However, I'm going to need to do a bit of research on that, because I'm not going to do that today, because refractions are a massive pain. Refraction is basically glass, right? So the light gets bent. However, it's very expensive to run, and yeah, I'm not going to do that at like 1:30. Sorry, no, 12:30. Sorry. So one thing I am curious of. Oh, it was on debug that was getting 12 FPS. Okay, was it? So let's try release. Oh, okay, release is much better. Okay, never mind. I was already scared. You know what I would be? I actually want to try something. So I want. Yeah, I have an idea. Okay. This is going to be a bit stupid. However, it's going to be cool. Right. So application. I think this would be good for the next stream as well. This would be preparation for that. So we know that reflections now work, and I want to do the following. Okay. So this is fine. This can stay. No. This will be commented out for now. Right, comments and comment. Model data. Okay, let's put this here as well. This can be commented out as well. We don't need it. And of course where do we create cal1? Oh, this is a global. Okay, that should be gone as well. We don't need this. We don't need this. Oh yeah, we had this in here for the line here. Okay. Okay. So we don't need this anymore. Same with this. Right, so this should still run, and then it should be a completely empty scene. Yeah, okay, that's good. That's perfect. That's what I want. So now I want to create a simple for loop, for e, and let's say 1,000, right? So I want to say auto model is, and this can copy from here, right? So auto model right, and then we would replace this with model, and then this. Oh, model, 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 right? And the position would be a GLM, I think there's like a sphere random in GLM. Right, so there is the hashtag include GLM random. No, it's in GTC. No, sorry, GTC random, right? And then there is the GLM spherical rand. What I think simply takes the, sorry, it should be the ball rand. A ball rand, and this gives me a radius. What would be, let's say 50 units, right? And this can be just in here, and this would be a GLM I think this could be just, what is linear rand? Okay, yeah, this would be a linear rand. Okay. Right, let me read what you sent. Okay, so your eye can only pick up brightness and RGB. Yeah. Oh yeah, because you only have you have like the cones and the other things that pick up color, right? Sure, it creates a spectrum. Yeah. Yeah, because you only have the things that respond to the like the three primary colors. Yeah, rods and cones. Thank you, man. I forgot the name. So because, yeah, exactly, the rods and cones. So I forgot the term because in Dutch we call them obviously in the Dutch terms. So yeah, so the rods and cones, that, yeah, they mix them, I guess, yeah. And I remember, yeah, because you need a signal to basically register the color. I'm wondering if that's also how color blindness works. So your brain doesn't tolerate or doesn't recognize it can't distinguish between those separate colors or thresholds. Yeah. So there, I mean, I don't know if you've ever looked on the internet, but there are like I mean, of course, sorry, that's a bit wrong. You have these memes on the internet where it's like colors, men versus woman, and then you have men blue, and then you have like woman, like 5 times of colors. Right. So one or more concepts are inactive, broken. Okay, that could be interesting. Yeah, sure, no, that makes sense as well. Right, so it could be that your green cones, for example, don't work as well. Oh, whoops. So your green cones don't work as well, so you can less easily distinguish green colors. Okay, something like that, right? That would make sense. Okay. No, sure, that makes actual sense. Then I want a light here. This can be at 0. I do think I would need, oh sorry, this should be at like 100. And this would need a bigger intensity though. And this would be at 0, 0. I think. Right, okay, so that's how color blindness actually happens, okay. Sure. Oh damn, this runs. Ooh, it's not happy with that at all. This, I would call this art. This is honestly art. Does the frame work on tuples of colors or? That's a good question. No, I think honestly it works with integers at least, because like I swear I can only see like 3 different colors. So it's definitely not floats, because then we would be able to see everything. So it's definitely RGB, because our colors are limited. Yeah, it's a hard question. No, but I'm actually coming back to Raytracer. I'm actually really happy with this performance. So this is running at half a frame, what is pretty impressive, I think, because we have implemented a BVH on model level. However, we haven't implemented a BVH on scene level. So that means that it still has to check for 1,000 potatoes. But that also means I think a single potato has... Let me actually check real quick how many triangles each potato has. Right, so this model data. What do you think, man, actually? How do I pronounce your name? Is it McBlank Ziviuski? Or would it be fine if I say McBlank? Or how do you want me to pronounce your name, man? It's I don't quite know how to say it. Model data. Miko. Okay, no, that sounds good. Right, so I just checked, and this model is about 27,000 triangles. So that means that we're running quick calculator. So I said 27,000 triangles times 1,000. So that means that we're running 27 million triangles in yeah, it is multi-threaded. Okay, wait, let me it is actually okay, so this is actually pretty cool. Let me wait. Yeah, I have a monster GPU. Wait, look at this. Oh wait, I can't even, it's not even showing all of them. Okay, there we go. But yeah, I do have a monster CPU. I might have gotten a bit overkill. Yeah. But let's not talk about that, right? Let's talk about the performance and not about the monster CPU. Right, no, but even then, even though this is very overkill, it would still mean that we're running 27 million triangles in about twice a frame. What I think is decent, especially considering there is no scene beer. Yeah. Oh, so yeah, this mode actually I haven't talked about this that much. This is a normal mode, right? So I don't know, Miko, if you're familiar with normals and what they are. Yeah. Okay. So this just shows the normals. Yeah. Exactly. So this can be helpful with debugging, just making sure that there's nothing weird going on with the textures. And same with this. This is another one that I implemented last stream, and I don't know if I like it too much. I don't know if I like it too much as I try to change it. Right, the UI isn't very happy, it seems. I might really need a separate thread for UI. Okay, let me rerun this and put this to like 50. Cones need some level of brightness. Your eyes have a dark mode. Variables amplify the sensitivity. Yeah, no, I did actually note that, right? So, yeah, rods are extremely sensitive, like you said, Miko. But yeah, only grayscale. So that means that even in the dark, we can see relatively well because of cones. Sorry, rods. Yeah, exactly. But this is a different mode, the depth view, and it's basically on the blue scale to see how deep something is. However, I don't like it that much. I don't think it's very clear from this how deep something is in the scene. But it's an option, so I can show at least the depth. Yeah. But Miko, have you ever made a Raytracer? Did you ever notice a small circle of... Wait, really? Wait. So if it's dark, you're I don't think I've ever had that, or at least I haven't paid attention to it. Yeah, you got a book. Oh, awesome. Yeah, I mean, if it's only in the dark, right? Who cares? Just turn on a light and you'll be fine. I mean, you got 2 eyes anyway, so it's fine. But yeah, I've got a bunch of books as well. So I've been currently reading this book. It's actually really, really good. This book. It's quite hard if you're new to C++, but it's really, really interesting. Oh, the author, it's... Let me actually write it in chat. Yeah, no, I know the chat rules, I wrote them myself. Thank you, Twitch. Anthony Williams. Right, there we go. It's a really good book. It explains everything in multithreading for C++ very, very well. Is it Kaini? Yeah, Kaini, right. C++ as a beginner, it's doable, but I would say it requires determination. C++ is a massive pain, to be fair. But I think I really like C++, but it's very hard to get into because everything you try to do takes about 5 years. Yeah. However, if you do want to start with C++, I do recommend the book. I might have the book. No, never mind. I don't have the book. I lended the book to a friend. However, you have the following book. Let me. Michael. Right. So you have. Yeah, you have this book by Michael Dawson. Right. You have this book. What goes? It's basically an introduction to C++, by using games. Yeah. No, Beryl, I didn't know about the blind spot, but isn't the blind spot a bit more, not in the center of your vision, but a bit more, like a bit to the right and left of your eye? But anyway, yeah, sorry, to round off the C++ thing, you can definitely do that, but it requires determination. If you don't want to buy a book, I can also recommend the following. I can recommend this. Yeah, okay, that works as well. So this is personally what I use to start into getting into C++. This site is very, very detailed, and I think it explains things very well. However, you have to like it's kind of dry, right? It goes into a lot of details, and you kind of need to be interested in it. The Michael Dawson book is a bit more playful in that sense, right? Because it's making it basically forces you to make simple games and stuff like this. This side is much drier, so it will be like this is C++, but not mentioned in the games. But I think it's a good source for the language as well. Wait, wasn't it the other way around? Didn't you have? I thought you had rods in the center of your eye, and the. No, no, no. You're actually correct. No, no, you are correct. Because I remember you only have a very small portion of your eye that's actually focused and like has full color support. Like I think it's like a very like if this is your vision, right? Like this entire region, the entire webcam, like you only have a small dot like this that is like completely in focus and sharp at once, and the rest is much blurred. However, in reality, your eyes are basically scanning everywhere. No, I really don't mind. Uh, it's fine. Don't worry about it, man. Um, but yeah, oh yeah, right. What I wanted to do. So the potatoes are cool, but the potatoes are too slow. Um, so you might be able to. So okay, one of the things I can show you. So what we did. Potato. Okay. So let me share my main display. Yeah, I know, right? So if we go to display capture, yeah. So the BVHs are quite expensive to make. So if we delete this file, right, it's going to take a few seconds to build the BVH. It's running, so it launches, it's building the BVH, and then it runs, right? So that is relatively slow. However, when we go here, we can see that it now creates a file. This is a binary file that contains the entire BVH and right, so it contains the entire BVH and all the triangle informations as well. And it basically loads this and just sets data. So if we now run it again, it should be done almost immediately. And you see that it loads much quicker. So this is cool, but we can't do this for a scene because the scene might change, right? So all the potatoes might be rotating. So we need a new BVH that is much quicker to build. So we can go through the scene to get the correct BVH, basically. What is going to be interesting, but I think it shouldn't be too hard because the principle is still going to be very similar. I think we can pretty much keep the entire BVH structure actually. If we change it a little bit, I think it should be okay. No, I think we're going to need to change that. Okay. So let's go into the BVH. Right. So, okay, so coming back to biology, right? Because we're already on this topic anyway, so we might as well continue. So something that always amazed me, right, is I see this color as black, right? Visual Studio, the background, or gray, whatever, it doesn't matter. However, there's no way for me to say that the gray I am seeing is the same gray that you're seeing. Like, what I see as gray might be green for you. Or, sorry, if that makes sense, right? Oh, sorry. I didn't want to be racist. This is dark white, my bad, sorry. I forgot we can't say that here. Oh, imagine being like, oh yeah, can you pass me the dark white milk, please? Thank you. Instead of chocolate milk. Or which color do you like more? The dark white or the white? Yeah, I like the dark white more actually. Right. Sorry. Right, so I've been just thinking how to approach this. Sorry for my quick silence. So I'm thinking if I want to extend the BVH or So no one has the same cone, so no one has the same color profile. Yeah, no, that makes sense. What about twins though? Because I'm guessing they must have very similar. Okay, even twins, okay. Cool. But I mean, it's also something, right, that you can't test. Like, whatever the case is, like, it is what it is, right? Like, because everybody grows up with the same definition but different values, if that makes sense. So everybody, for everybody, this is dark white or gray, however you want to call it, and even if the perception is different, they all still refer to it as the same color. So it's like an impossible problem. You know that potentially they see something different, but you can't tell. It's the same with I don't know if you've ever heard of uh, amaphasia. It's I forgot the exact term, but I think it's basically where you can't imagine, like you can't see objects in your head. It's like your mind's eye or whatever it's called, right? It's been, yeah, no, mind's eye, right? I think it's like a fancy medical term, whatever you call it. Um, so yeah, sorry, yeah. So there's been doing more research about it lately. It's been getting a bit more attention. So it's basically that you can't imagine things in your head, for people that don't know what it is, right? However, um, it's really hard to think about because it's normal for you, but I might think that I can't imagine things. However, what we both expect from it might be different. So maybe I can do the same, but I don't know what to expect. So I think I can't do it right. So it's so hard to imagine what somebody can really think and what you can think and see how they compare. Because you can't see through somebody else's mind. So maybe you, some people can actually see like cities in their head, but and other people can't, or everybody can potentially, but they think they can't because they don't know what to expect from it. It's like too high expectations, so they think the wrong thing. But yeah, it's an interesting topic. I really like these type of things. But yeah. Right, but trying to say on programming. Yeah, right. So my issue that I'm having is I basically need to go through all BVHs and find the extra correct intersection. So I think I need to tie this in here. So if I go traverse, it goes through specific models. I think that would work, sure. When I was younger, I kept expecting to be able to just run them. Yeah, that sucks, right? Science hasn't gone that far yet. Or like think in like magical worlds, right? Yeah, it kind of sucks, but yeah. Right. So I think we can slightly change this code. So we now here have a pointer of nodes. However, we can simply, what I think is the best, we make two BVHs in the BVH structure. Oh, no, we can't actually do that. Ships. No, we need a different class, and that will reverse the BVH like normal. However, once it finds a node that it hits, and that node is an actual node, so that would be a model BVH, it then goes into there, see if it hits an object, and basically does the entire magic thing, right? Huh. Ooh. Yeah, I'm really curious, like, so one, yeah, they're all what you'd say is an interesting point. I'm actually curious how much calculation power our brain really has, right? Because if we compare it to, like, say, raw computational power, right? It might be a lot, or it might actually be very little. Because although our brains are very complex, like, our raw, like, number calculation is very slow. A computer is 200 times faster. However, we can make connections that a computer can't. So I'm curious, like, in raw power, how much power we actually have. Right. But yeah, I was trying to do programming and this is kind of derailed. But, I mean, that's fine, right? So let's do a new class called scene BVH. Oh, yeah, you can't see the pop-up, my bad. I'll just create the class real quick. Scene BVH. Right. Okay. So we got this now as well. So is the BVH node in here? No, it isn't. Okay, that's great. So we need to include BVH node. So this would be core BVH node. And this would be in namespace RT. Right. And I think I'm just going to write the interface for now. So this would have a public, and this would have a build BVH. And this would take in a std vector, and this would have a class. Is it model? Is model a class? Yeah, I think so. Struct model. Sorry, a class model. And then we need to include memory as well. You can achieve by pedal running and that is actually fair. Do you guys think that, or yeah, so Miko and Beryl, that we will be ever able to simulate a brain? Like fully, right? Because I personally think we will be able at some point. So the thing is, so let's say we can run technically a brain, computing wise. Would that brain be distinguishable from a real human? I don't think it would be, if we would have the power to run it and could actually model it after a real brain. I think it would be indistinguishable. So we would have a build here, and then we have a private. This would be BVH node pointer and nodes. Right, and this is equal to a null pointer, right? Sure, and then we would have. No, we don't actually need to resize this, so we can have a uin32t num of nodes, right? Because we don't actually have to allocate memory each time. We only have to do that once. Because although we might have to change it, right? Okay, no, we can do this. Okay. So we have a build BVH, then we need some private functions here. And this can be taken from the raw BVH. So this would have a subdivide and partition. Yeah. Oh, and then we need this as well. We need an e-axis as well, of course. However, I think what we could do is just move this out of here. So, yeah, sure. Yeah, include BVH. Oh. Right. Yes and no. A highly advanced neural network can theoretically replicate the same output. Yeah, so I was thinking the same, right? The inner process would be different, but it would simulate the same thing. So I'm wondering if that would produce the same result in the end, right? Right. So we have the partition, we have the subdivide. Then we have a void. No, sorry, this would be. We have a BVH. Yeah, so we would have these two. Right. And this takes in a acid vector of models. So slightly different, right? No, does this stick in all the models? Yeah, it does. Sure. Yeah, because this would be rearranged, the models themselves. Okay. And then the subdivide, I think these both took in the model, or did they take in? Yeah, they both took in the model, okay. Right, so this is something very similar. And this needs to be called every frame, the build, right? And then we intersect, and this goes in over all the models, and it has a light traverse for earlying out with a light. So if we just hit anything. And these would basically go over the models and get the correct model based on this BVH. And that should be good. Okay. So build BVH. So I think we can do this very similarly to the real BVH. So we had build BVH, and this does this, okay? Subdivide. And this would be models.size, right? And this would be m.nodes, and this would be, right, we would need the bounds of the entire scene. So we would say to do calculate scene bounds, and this would be models.count, models.size, sorry, right, and this would be m.nodes.0, right, this would be the box size, yeah, okay, that's fine, and this would pass in models, and this would pass in m.node, okay. Oh, we need a different subdivide info. Right. Because this is, yeah. Right, that's never going to work, okay. So we need this in private. And then in the scene PVH, we have this as well, and this takes in this instead, the vector. Yeah, it would be this type. Model. This would be models, right? Ctrl K. And we pass in models, right? And then we call it subdivide. We know we do have partition info, right? Oh, but this is RT. This would just be partition info. Or let's just delete this function and remake it, because that's easier. It's empty anyway, right? So then we have this. So this is pretty much the same. And then we would, in here, we would say if no, we would still say this. So if m.nodes is greater than, sorry, if m.nodes doesn't equal that's right, m dot number of nodes, so if nodes does not equal m dot num of nodes, then we want to say m dot num of nodes is equal to nodes, and then we malloc, and then we say if m dot nodes, so if that so if that's not equal to null pointer, we would do a line free of m dot nodes, right? So we check if it's not equal to this. That means, oh, we have a change BVH, we free the memory, we set the number of nodes here, and we allocate memory, and then we do the rest. Okay. Sure. So we would say glm vec3 bounds, and this is a vector of 2. So we would go over, we do a for each over the models, and this would be an auto reference, right? Then we would say bounds.0 is equal to glm min bounds.1, that's for bounds.0, comma element dot model data dot bvh or dot bounds. Okay, cool. Although we want to get the bvh bounds. No, I think that we can just actually get this bounds. And this would be equal to the following. This would be infinite, infinity, infinity, infinity. Oh. And this would be minus infinity. And minus infinity. Then we do the same here for the other parts of the bounds. And then we do instead max. Right, and this should give us, this should go over all the models and give us the bounds, right? And then we simply say node 0 equals bounds. Okay. And why does this not work? Because this, oh, it should be an std array, sorry. STD array of glmvec3, comma 2. And then that should be fine. Oh, it probably doesn't know that this is a glmvec3. Yeah. So you need to specify that. Okay, cool. So it says bounds, bounds. Okay. However, I think this is wrong, potentially, because this doesn't take the transforms into account at all. What is kind of a problem? Because before we would take in, I'm considering if this is a problem, because I think we want to build this BVH in world space. And then intersect the other BVHs in local space. What is interesting? Yeah, you know what? I think I should sleep. Because now we're actually starting with some quite hard problems, and it's getting late. So yeah, I think I'm gonna call it here for tonight. So yes, for everybody viewing, if you want, you can drop a follow, and you get notified next time when I'm streaming again. What will probably be tomorrow, and that will be probably around 6-ish GMT +1, and I will probably be streaming again. Although I might not be streaming the Raytracer, I might be streaming some gaming. But yeah, definitely do drop a follow if you want to be notified of me streaming again. And I want to thank you all very much for joining the stream tonight, and I wish you all a good night. Thank you for following the stream. Yeah, thank you, Barra, for joining.